at the Mobile World Congress in San Francisco. Isn't that like a European thing? I'm with Jason.
Yeah.
We've known each other a long time, right?
Okay.
It's been a few years since we've seen.
14 years.
Yeah, I did a minor retirement there, but I'm back.
Yeah, we all do.
Yeah.
Yeah, we all do.
So you've gone over to the Ericsson side.
Yeah, I retired to Sweden and then I've been helping the Ericsson guys.
Nice,
Yeah,
nice.
yeah.
For those who are not familiar with Jason here, he was one of the founders of Joint back in the day, which was probably the first cloud service provider. I don't think there's anyone before you.
It's the oldest surviving other than the SunGrid.
Yeah. So and what I always talk about you guys, because what was interesting, you guys were based on this idea of containers before containers became as popular as they are today.
Yeah.
So you sort of knew that was the right sort of metaphor for sort of deploying these apps.
Yeah.
So maybe let's reminisce a little bit.
Okay.
Let's go back.
Yeah.
So back. What was the driver? Why did you want to go and create sort of a cloud computing company before cloud was even a thing?
Well, I mean, back then we called it a grid container service.
Yeah.
The attraction around containers, like always, is basically performance and security. You got to sort of think back. This is 2003, 2004, right? So it's roughly the same time that AMD was shipping the first 64-bit x86 chip.
Yep.
It was 2-3 years before Intel shipped really their first 64-bit x86 chip. So the typical hardware-assisted virtual machines and large memory systems didn't exist.
Yeah.
Right? I mean, you're talking about servers back then that were 4 gigs, 8 gigs of DRAM.
And those are kick-ass servers.
Yeah. So a lot of the push back then is if you decide that you're going to be multi-tenant in those types of environments and let people schedule different workloads and run it, the only viable sort of virtualization technology back then was OS level virtualization.
Yeah. I was using the very, very first version. We started our company in 2003 as well, and the first version we based it on something called UML, User Mode Linux, I think is what it stood for.
Yeah.
And I remember going to a bunch of investors and pitching the idea. We called it elastic cloud computing or something, big long, thing, and all,
cloud.
Elastic Cloud, and everyone was like that. One, it's what's this UML? It's craziness. No one's going to want. You're looking at a massive overhead, and anyway, it took a while. We always pointed to you, so it was.
Oh, that's good.
It was like they're doing it.
They're doing it. Look who they're hosting.
Yeah. So it's cool stuff, and so Joint was sort of an interesting thing.
Yes.
It
still exists.
Still exists.
You can still go to joint.com and buy what you could buy 13, 14 years ago.
This is probably a conversation for another time. I would imagine that company would have been bought years ago.
It was bought by Samsung.
It was?
It's owned by Samsung today.
Okay.
Yeah.
So it was bought. It's just...
if you're using a Samsung phone and you're doing the facial recognition on the phone, the whole back end of that is the Samsung Cloud, which is Joint.
Okay. Well, now, so for us, it's VirtuStream.
Yeah. But so then they do sell to other people. Right? So you can still go there and use it.
Okay, cool.
Yeah.
So now you're at Ericsson.
Yeah.
So what's going on? What are you doing over there?
Well, when I first came on board was to run their infrastructure and platform business. And then we started calling that the cloud business. But it was the entire data center hardware and software platform business they were doing.
So you're looking at the tooling. Is that software and hardware, or just software?
Yeah, all of it.
So helping enable telecom operators to be cloud providers, or?
Yeah, well, I mean, the thinking then was on one end of the infrastructure is like all the radio base stations and the radio infrastructure, and that is the world's largest algorithmically driven, event-driven distributed infrastructure.
Yeah.
So everything your phones connect to. And then, of course, on the other end, there's tens of millions of locations for that. On the other end of the spectrum, there's a few hundred data centers for large-scale cloud providers. Now, if you look at all the infrastructure in between those two things, if you're using a mobile app and you're talking to a radio base station, but the app is on Amazon, there's actually about 3 layers of a lot of other infrastructure in every country that basically existed.
The routing and whatnot?
Well, not just the routing, but there's things like where does identity live for this, how you actually do the networking itself, and the like. But there's roughly 10% of the world world's server market, 10% of the world's storage market, 10% of the world's networking market, that is in sort of this middle mile infrastructure, in between sort of the radio edge and large-scale cloud providers. A lot of the push there was to industrialize that, taking some learnings from how we did radio and some things about how large hyperscale clouds work out, and just start driving a process where every operator in the world has an actual middle mile platform that works with each other, and then we can virtualize all the telecom workloads on top of it. Those sorts of things.
So 5G obviously being a part of that, and
yeah, that sort of industrialization of the middle mile is a prerequisite to be able to do 5G. Because 5G starts disaggregating radio and pushing control systems down, and that cloud infrastructure's got to be capable of doing things like radio control.
Yep.
And it's also got to be something that we can start doing other interesting things with.
Well, I think the challenge with 5G is there's a stigma around that they sort of transformation from 3G to 4G, which was almost purely bandwidth, and now there's this 5G tech, which is obviously partially bandwidth, but mostly like segmentation and other sort of things that
latency as well.
Latency, and I think for the sort of uninformed, it just seems like, oh, it's just faster, right? But it's not. It's more than that.
Yeah, it's a little bit more than that. Meaning the sort of radio network side of things, like the mobile network side of things, is typically hasn't been virtualized historically. Meaning, that you can have one physical footprint, but then you can run many sort of virtual mobile networks on top.
Is that like an SDN sort of overlay, or?
No, it's really like typically what people call network slicing, or the ability to be multi-tenant with the mobile operator on the same piece of gear. So, rather than having sort of 4 mobile operators in a country each deploy out all their own physical equipment, you can do one physical deployment, virtualize those networks, and then you can also then do network slicing, where then you virtualize it per industry, so that you can do an end-to-end connection that may be different for gaming, than for machine-to-machine workload, than for somebody that's accessing the website. So you got to think of it a bit more like, being able to do large-scale mobile VLANs on a per-customer basis or something like that. But yeah. So this idea that you can start doing multi-tenancy, and you can start slicing the network up and really sort of secure end-to-end channels in that's definitely one part of it. I think the other thing that happens with 5G is normally, like when you go to make a phone call or you go to use your mobile phone, the initial sort of connecting to the mobile network has historically been the slowest part of everything.
Yep.
Now it's not. And because it's not, then all of a sudden, then the stuff that happens further down in the infrastructure becomes more important, in there. So there's a little bit of a story around latency. And then the capacity story, you got to keep in mind that, there's 5G things that are greater than 1 gig, greater than 10 gig. There's people that are demoing 5G at 50, 70 gigabits per second. So you're also at the point now where 5G technologies over the next few years are faster than any fiber you run to home.
Okay.
So this sort of idea that your home's all the broadband connectivity you have in your home is basically over 5G, but it's better than any sort of fixed line you can essentially get as a.
So you're replacing the need for like Wi-Fi networks, or?
Yeah.
Interesting.
Yeah.
And does that address things like energy use for IoT devices that, where a 4G connection just sucks the battery back?
Yeah.
One of the challenges with my little setup here is LTE. The LTE connection just drains. Like right now we're streaming at 4K, drains that right back.
Like when you look at a lot of the stuff that popped up for 5G, being able to go to very large, capacity and throughput more so than what you get from a fixed line was one of them. The latency was, of course, the thing like what we already talked about. The ability to sort of, do rapid access times and connections was it. The other one is the idea that you actually have things like a low wattage battery in a sensor device that's got to last 5 years.
Exactly.
And you're not going to recharge it in 5 years, and then basically making sure that yes, that radio connectivity doesn't totally.
Well, a lot of folks are using like 2G, or
No, I mean you notice even on a typical smartphone, if you basically put it in airplane mode, you don't have to charge it for a week.
Yeah, exactly. It's
right. And it would be nice, as you can imagine, if you start looking at the ability to start having 5G enabled smartphones where one of the basic experiences you get as a consumer is you don't have to charge your phone for days. That's okay.
Yeah, or at least an option to go into like low power use mode, and actually have some useful components on my phone. when you switch to airplane mode, it's kind of useless.
Yeah,
you know, if you spend any time on an airplane, you know. Yeah. You know, so you've always had an eye sort of for the future. What's coming down the pipe? What's exciting?
What's coming down the pipe? I mean, part of it is, so on one hand, I think there's a lot of interest in. I mean, we sort of talk about hardware as a commodity, for example, and what software does, but there's almost this constant interplay between hardware and software, and I think what you see is the emergence of a lot of commodity hardware that traditionally has been pretty specialized. I mean, so now you're starting to see that it's not just x86 chips out there. There's like hundreds of commodity FPGAs that are thousands of times faster to achieve like a given workload. You're starting to see a lot of activity in the GPU space. You're starting to see a lot of activity in specialized chips for machine learning and the like. So we've actually had a pretty big explosion of specialized but now commodity and readily available hardware. And as you can imagine, if you typically look at a workload that takes 3,000 servers, now you can do it in one server because you're actually using an FPGA or a GPU or a specialized chip. That's pretty interesting. We're also doing things now where when you look at everything being optical end to end, where even the NIC that lives on normal servers is a full onboard silicon photonics and the like. Starting to flatten this world down to like a big optical L1, that's got a bunch of different, hardware acceleration capabilities and those types of things in it. And then even in the networking space, when you look at like the next generation of routing and switching chips, you're actually allowed to do like full programmability of L2 headers and these types of things, which sort of blows a big bomb up in the middle of the whole SDN spaces that exist and the like. So I think one big area is there's a lot of really interesting new hardware that's going to be driving new software architectures, new capabilities. So that's one big one. I think on the software side, I find it really interesting that we're now finally sort of making this transition to very data-centric, data-intensive type architectures. So when you start looking at these things, you can bring stuff up into microservices and each have their own database and how they're talking. Being able to drive that to like a common log format and something like Kafka and Swans and a lot of those types of architectures that are emerging, those are really fascinating software architectures that are happening. But if you look at it, then it's not about the app, it's not about the network, everything's centered around a given type of data design, and it's assumed that it's going to be distributed and everything else. And the fact that it's becoming commonplace and not just something that exists inside of a Google, that's a pretty fascinating area. And I think the third one is, a lot of the times when you're going out and doing this application development, it's like, you go and you make something, and then you manually figure out when you should automate, and you manually sort of implement the automation, and you manually go and determine use cases, and you manually optimize it. The fact this all gets sort of flipped around to now I can instrument everything that's actually going on. I can drive that to an optimization process that's based on every possible sort of machine learning and AI type thing. That then can actually do all the automation, including automatic code generation and everything else. That becomes pretty interesting. I mean, so we have some things within my group. I mean, we do things where we haven't like manually coded APIs or SDKs or anything like that in years. That's just automatically popped out of a build generation from a common data model. There's some things now where they're being sort of entirely flipped on their head that I think is pretty interesting.
Yeah, it's funny. When I was getting, one of your guys was telling me about the network AI stuff. And it's like, it's the holy grail. I don't have to worry about this stuff. I don't want to have to, send a guy to have a pager or whatever he has to be notified. Yeah. So it's like the automation. Anything that involves people should essentially be automated. Yeah. It does open up some, societal challenges, I suppose, when we start automating all the lowest levels of everything to a point where we don't necessarily need people to do anything. But I think it does make us focus on the things that matter, higher level thought.
Well, and then the other area we started doing within a lot of this equipment and the network and everything else like that was when you started looking at very like the typical sort of Bitcoin blockchain, it's very distributed type architectures. We then sort of arranged that up in a tree as well. So there's a distributed version of decentralized and some sort of centralized services. And we started using, essentially the same crypto basis of things like blockchain and the typical ledgers to actually do, full integrity around identities, full integrity around hardware, software, or everything else. So we're starting to also introduce a lot of those crypto technologies to secure infrastructure.
It's interesting.
Oddly enough, yeah. Not to be a currency.
No, of course not. But for like a store.
Yeah, well, yes, exactly. But it's a bit more of saying, like, yes, we in fact know that software that's on that is supposed to be there on this, and it's supposed to this, and it's supposed to that, and that person. Being able to sort of rapidly secure that end-to-end.
The biggest challenge, I think, in terms of blockchain is speed. And and it is especially true of obviously currencies where you're forced to download an 80 gig wallet file. Yep. But even in the case of a private blockchain, the technology isn't exactly made for highly frequent transactions.
Well, and that's for us. That's why we tiered it out. So typically, as you said, is typical use in currencies is very distributed. You can also bring it up to another structure and then bring it up into something that's a bit more centralized. Now, the reason we came up with sort of a structure like that, where you can sort of pick where the ledger's going to be and pick where you're going to sign and pick where you're going to verify, up and down, is because then you get a choice of transactional speed. So if you can tolerate things that take a while down here, that's fine. If you need things to happen under a second, under a millisecond, then you actually go into a more centralized type structure.
So like an off-chain or Oracle sort of approach, where you have a combination of things that happen on and off the chain.
Yeah, a little bit, but that same sort of like transactional speed then is we just wanted to tier it out so that if you actually need to do things in millisecond, sub-millisecond time, you have that option, but it's a much more centralized type signing infrastructure than something that's out there.
The other thing that's been, this is something that my viewers hear about a lot, is this sort of tokenization, the token economy that's popped up in 2017. Everyone wants to create a utility token of some sort. Yeah. I'm sure this is something, I know you've got a sort of, interest in sort of, the utility model from going way back. What are your thoughts on sort of this emerging space?
No, but that's now, we're using a lot of those same technologies, but on the infrastructure side. So when you look at things where, typically you'll take a container, it'll have a 64-bit or 128-bit address, right? So now when we start looking at using a 256-bit token, that is the actual network identity of that container.
Okay.
So you got to think of, and I wouldn't call it IPv8, but it is sort of that next thing like that. You can, in fact, actually use 256-bit tokens like that as the network identity.
That's good.
And that network identity can basically self-verify the entire payload that's there. So rather than sort of an overlay onto the infrastructure and everything else like that, we're actually very interested in using the sort of, the actual like hash tree itself, the actual token itself, as the actual network addressable identity that you're sending packets to.
That's a cool idea.
And when you flatten that down, some interesting things happen. So.
One of the things that occurred to me...
It's it's like a core infrastructure implementation versus, something that's meant to make money, but I think it's a really...
Well, actually, as a chargeback mechanism, there's nothing saying that if you're segmenting your 5G network and offering certain, access privileges, that some kind of token-based component couldn't actually provide a source of value in terms of access. I've got X token, that gives you X amount of bandwidth or X amount of throughput or whatever.
Yeah, and you can imagine, eventually in the future it could be the basis of, it makes things a lot easier if you want to share bandwidth with your family, you want to sort of this, that.
Not everything needs to be $1. There's inherently, there's value outside of the traditional sort of form of fiat currency, and I think that's, for me, what's so exciting about things like the Ethereum network and being able to quickly create these sorts of, these tokens that based on smart contracts that say, if you use my platform, and so on. Like if I was to create Spot Cloud today, it would be based on Ethereum. But unfortunately, in 2009, Ethereum didn't exist.
Well, and a lot of my interest is you can take those same core technologies and everything else, then take it all the way down and use it as a basis of infrastructure.
That's cool. It's cool stuff. So I know we're running a little long here. I really appreciate you taking the time to come on the show today. If anyone wants to learn more about you and what you're doing, where should they go?
I'm Jason H on Twitter.
With Jason H on Twitter, really good to catch up.
Go to Ericsson.com/hyperscale.
And you still hanging out at that bar down the street?
No, I've been living in Stockholm for the last 3 years. Yeah.
Okay. The city built on stocks.
Yeah, and it's bars plural.
Oh wow. Okay, nice. I haven't been to Stockholm in a few years. I should get up there and see what's going on.
Yeah, but it's a great little town. I mean, it's got a ton of startup activity. I mean, there's things where think last year something like 80% of venture capital dollars invested in Europe was in software.
Yeah, and it's like like a huge app economy, like tons of mobile apps. And
Yeah, I mean, you have Klarna and Spotify and blah, 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 blah.
It's cool. Well, it's really good to. Let's just make sure it's not another like 3 years before I see you again.
It's up to you, man.
All right.
Talk to you later.
Yeah,
Bye.
I'll see you soon.